In this video lesson, I will present the main features of series and parallel circuits in terms of voltage, current, and resistance. This is a schematic series circuit showing all the components with symbols. We have here two light bulbs. One is represented by the abbreviation R1. The second one is R2. The switch is represented by the letter S. Here we have the total voltage that is providing the energy for the circuit, which is VT. And all these components, they are connected with wire. In this page, I will show the circuit description in terms of current, or IT, that will be the total current flow in the circuit, the total voltage, or VT, and the total or equivalent resistance, RT, that is not showing here yet. In a series circuit, all components terminals are connected in sequence. Once the switch S is closed, the same current flows through all components. The battery, labeled IT, through the light bulb 1, which is I1, and through the light bulb 2, which is I2. Switch and wires are also experience the same current. So because of that, we can state that IT is equal I1, which is equal to I2. And this is our first equation, voltage. VT shares its energy between all components of a series circuit. The voltage drop on R1 is V1, and the voltage drop on R2 is V2. So we can state that the total voltage is equal to the voltage drop on each resistor or light bulb in this case, which is V1 plus V2. And that's our equation 2. Total or equivalent resistance, RT, is the resistance that would replace the value of all resistance in a circuit. So here we have an example of a equivalent circuit. It is a type of circuit that simplifies a large circuit with many resistors. So now we have just one resistance or equivalent resistance that in value replaces the partial resistance of a schematic circuit. So now we have, for a complete equivalent circuit, we have our VT, we have our IT, which is the same, and our RT. So the mathematical sequence to determine RT is this. First, we are going to start with the equation 2, which is VT is equal to the voltage drop on each light bulb in this case. Now we are going to use Ohm's law that states that the voltage is equal to the resistance times current. Now we can replace this value on equation 2. Now we have RT times IT is equal to R1 times I1 plus R2 times I2. After doing our substitution from this equation, which is Ohm's law for voltage.